Mrs. Mousehami Mondal is a qualified teacher with 10 years of varied experience in India and UAE. She is an extremely passionate and skilled educator who demonstrates an ability to teach, motivate, and inspire students.
For today, continuity and differentiability. So let's first try to understand what a continuous function is. A function is continuous at a fixed point if we can draw the graph around that point without lifting the pen from the plane of paper, right? So let's see it on the whiteboard. What a continuous function looks like this, right? Or this, right? Or even this. Okay, all of these are continuous function. Why? Because I can draw them like this without lifting my pen from the paper. That means you can draw it on one go. So such kind of functions are called continuous function. You are getting it? Okay. Talking about the continuity of the function. So here we have a function for which it is x if x is greater than or equal to 0, right? So x means it's a straight line, right? So this x is in the form of y equal to mx plus c, where m or your slope of the line here is 1, right? So 1 times x plus c. Basically, we do not have the constant term here. The constant term for this function is equal to 0. That means our line equation is y equal to x. Alright. So for this y equal to x, we get a line which is exactly in the middle of the x and the y axis. Fine. And this line is drawn for the range x greater than equal to 0, right? That means it covers x greater than or equal to 0. That means a positive x-axis till x equal to 0, right? And for the latter half of the function, we have a quadratic function. This is the function y equal to x square, and it is applicable for x less than 0. Right? So you can see that this function is a continuous function. Why? Because we have the lines or the curve throughout all the place, right? Covering all the points in the x-axis, the positive x-axis as well as the negative x-axis, right? So this is a continuous function, right? If you can draw a function or a graph without lifting your pen from the paper, from the plane of the paper, then that's a continuous function. Okay. Then how does a discontinuous function looks like? So this is the graph of a discontinuous function. Okay, where we have fx equal to 1 if x less than equal to 0, and it is 2 when x is greater than 0, right? So you can see how it has been drawn. It looks like this, right? If we draw it separately, it looks something like this. Here we have a solid point and here we have a hollow circle, right? The hollow circle means that this point is not included. Why? Because it is 2 for x greater than 0, right? It doesn't say x greater than equal to 0. That's why the 0 line, that means this line, is not included, right? So this point 0, 2 is not included. So we have a horizontal line like this, parallel to the x-axis. Similarly, for the first one also, for x equal to fx equal to 1, right? see it is less than equal to 0, right? That means even the 0 is included. That's why we have a solid circle here. And that's also a horizontal line parallel to the x-axis. But both of these, they have breakpoints, right? We cannot draw this graph continuously, right? It looks like a staircase, right? Where you have gaps in between. When you climb up a staircase, what do you see? You see that you have gaps in between, right? We have to cover the gaps with our legs, right? So this function is also called a staircase function. Okay. And this is an example of a discontinuous function, right? That means where we have breakpoints in the function and we cannot draw the function in one go. Okay.